12.3, proving triangle congruences by side angle side. And then SAS is side angle side. So we have the side angle side congruence theorem, which states that if two sides and the included angle, and I'm going to put that in a box here for a minute, that's important, of two triangles are congruent, then the triangles are congruent. So let's take a look at what this actually means. In section 12.2, we knew that two triangles were congruent if all of the sides and all of the angles were congruent. This theorem is saying that we actually don't need to prove that much information, that if we just have one side and then another side, and then also the included angle. The included angle is the angle that is between the two sides. So I have side BA and I have side CA, then angle A is the one in between them. If I was looking at angle B over here, that is not the angle in between those two sides, so it's not the included angle. So if I have the two sides are congruent and the angle in between are congruent, so angle A is congruent to angle D, then I do in fact have enough information to conclude that triangle BAC is congruent to triangle EDF. And the reason would be because of the side angle side congruence theorem. Example 1, writing a two-column proof. We are given that side BC is congruent to side DA, which is marked with one tick mark on our picture. And we're also given that BC is parallel to AD, and we have to prove that triangle ABC is congruent to triangle CDA. Before we look at this too closely, I'm going to set it up. I'm going to put my work. I'm going to put my reasons. And then remember, number 1, we are always going to start with the given, or at least part of the given. In this case, I'm going to put it all in there, and I'm going to say that BC is congruent to DA, and then I'm also going to say that we know that BC is parallel to AD. And if we forgot, that marking right there means parallel. Now, if I want to prove that these are congruent, one way of doing it is showing that all of the sides and all of the angles are congruent, which it really doesn't look like I'm given enough information. Right now, I'm just sitting with this side is congruent to this side. So maybe I could try to use the side angle side theorem, which means I would just need another side because I already have one and I need two. Well, in order to do that, I'm going to look at AC. Do you notice that both triangles, this triangle and this triangle, both share AC? So AC is congruent to AC, and that is your reflexive property. And then don't forget to go back and actually write given. So now I have a side and I have another side, which means I just need the included angle. Well, the included angle is the angle in between the sides, which would have to be this one and this one. In order to do that, I know in the given that these two lines are parallel. They are cut by a transversal, and these are alternate interior angles. And we know that alternate interior angles are congruent, so in step 3, I can say that angle BCA is congruent to angle DAC. C because they are alternate interior, and that is the alternate interior angle theorem. So now I have enough information in step 4 to prove that triangle ABC is congruent to triangle CDA, and the reason is because of the side angle side congruence theorem. And for that, you can just write SAS.